So students, now we are going to discuss about the maximum height attained by a projectile which has been thrown from ground and which also lands on the ground. If we talk about this term maximum height, then we can very easily understood the meaning of maximum height here. Obviously, during the flight of the projectile, it rises up to a certain maximum height. And after achieving that height, in the further motion, it starts descending and again reaches on the ground. So here, our main aim is to find this maximum height. We will proceed with it in a very simple mathematical manner. So students, we are talking here for maximum height. Say a projectile has been fired from this point, I will call it point of projection, with a certain velocity, say u, at an angle theta. Then what will happen? You can easily imagine that the path followed by this projectile is somewhat parabolic path. We have seen it in our earlier lectures that if this projectile is thrown here in this direction with velocity u at an angle theta with the ground, no doubt in our previous studies of this projectile motion, we had considered a particular reference frame as the xy coordinate system with x-axis along the horizontal and y-axis along the vertical. So I will here also stick to the same imagination. So for our further study, I am taking x direction to be along horizontal and y direction to be vertically upward. We know that in this entire region around the projectile and its range of motion, acceleration is always vertically downward, having value equal to g, the acceleration due to gravity. Now, it can easily analyze that while it reaches at the maximum height of this path, obviously at this height, vertical component of velocity is 0. If vertical component of its velocity is 0, then we can very easily use the third equation of kinematics, which is basically the result of work energy theorem. Here, by conserving the energy, we can easily get the velocity in y direction to be 0 at maximum height. So what we will use here, we will use equation Vy square, it is equal to Uy square plus 2 times the acceleration into displacement s. Here, to calculate the maximum height, we will utilize this equation in which h will be considered by us as h. Acceleration a, it is g vertically downward. So I will put it to be minus g. And obviously the initial velocity in y direction, which is the y component of its velocity of projection, having the value equal to u sine theta. So I will put uy to be u sine theta at maximum height. This velocity y, Vy, will be taken as 0. Using these values into this equation, we can write 0 square Vy square. So I have put here the value of Vy at the maximum height to be 0. So 0 square, it is equal to u square sine square theta minus 2 times g into h. Here h is maximum height of the projectile. So by using this equation, a very simple results come out, which can be written as u square sine square theta divided by 2g. This is the required result for the so-called maximum height attained by this projectile. Here we can also consider it as u perpendicular square upon 2 times a perpendicular. I have put this relation into this form just for some uses in the other cases of the projectile. So just remember it in this form. It will make easy for us to consider and to evaluate the maximum height attained in various cases of projectile. Here we can also say that in case ball or projectile is thrown vertically upward, then it reaches up to the maximum possible height which can be achieved by that particle with the same velocity. So we can also write one conclusion that for theta is equal to 0, that for theta is equal to pi by 2, h becomes u square by 2g, which is the maximum possible height up to which a ball or a particle can be thrown with the same speed under the gravity. So what we have done here, we have obtained the maximum height for the projectile thrown from ground under the gravity.